Let's take a look at the wiring for this partial discharge test. The output end of the peak meter should be connected to the bottom of the voltage divider. The high voltage end of the voltage divider is connected to the excitation terminal. The two excitation leads are connected to the low voltage side of the main transformer. The terminal screen on the high voltage side of the main transformer should be connected to the impedance unit of the partial discharge system to allow the signal to return. It can be seen that the compensating capacitor is connected to the 35 kV tab. Only one capacitor has been installed, and the others have not been activated yet. This should be adjusted based on the actual field conditions. Here is the excitation transformer. The low voltage side of the excitation transformer is connected to the power supply frequency converter source via the thick cable we saw earlier. Then, there is grounding. There is a grounding point here for the excitation transformer. This is the one we needed to disconnect when we removed the cables earlier. This grounding point is directly connected here. The excitation transformer can have multiple grounding points. The excitation transformer has 3 sets of contacts in total. The cable below is connected to the peak meter. Overall, the wiring is relatively simple. First, the partial discharge instrument is connected to the impedance unit, which is then connected to the terminal screen on the high voltage side of the transformer to capture the signal. Next is the peak meter. The peak meter is connected to the bottom of the voltage divider for signal acquisition. Then, there is the control console of the frequency converter source, which is connected to the control end of the frequency converter source via fiber optic signal cables. The output of the frequency converter source is connected to the excitation transformer. The excitation transformer then applies dual direction excitation to the low voltage side of the main transformer. The low voltage side is in the middle, and cables are routed over using cable racks. Compensation can be applied to various high voltage taps. The fiber optic cables are inside that white box. Large cables are used here. The field wiring is relatively simple. We are currently packing up the cables. Note that both the high voltage side and the medium voltage side are covered with protective caps.